The Big Bang did not bang. There was no sound, no explosion, no shock wave rippling through the cosmos like thunder across a midnight sky. There was no moment at all. Not in the way you understand moments. Not in the way you experience time passing as you read these words, as your heart beats, as neurons fire in the electric storm of your consciousness. Think about that for a second. Really think about it. Everything you've been told about the beginning, every documentary you've watched, every textbook diagram showing that dramatic burst of light expanding from a single point, it's all a metaphor, a lie wrapped in convenience. Because the truth is so strange, so fundamentally alien to human experience, that we had to invent simpler stories just to cope with it. But what if I told you the lie goes deeper than you think? What if the very thing you're using to read this right now, light, bouncing off your screen or page, flooding through your pupils, triggering cascades of chemical reactions in your retinas, what if that isn't just illuminating the universe? What if light is the universe? What if light didn't just appear at the beginning of creation? What if light is the creator itself? You might laugh, you might scroll past, but before you do, let me ask you something that will burrow into your mind and refuse to leave. If the universe began as pure energy in an infinitely dense point, which physicists assure us it did, and if energy and light are fundamentally the same thing, which Einstein proved they are, then what exactly is the difference between the universe and light? None. There is no difference. The universe is light, was light, will always be light, just wearing different masks, playing different roles in the grand performance of existence. But I'm getting ahead of myself. Let me take you back. Not to the beginning, because there might not have been a beginning, but to the moment you think you know. The moment that supposedly started everything. Close your eyes. Imagine nothing, true nothing. Not darkness, because darkness is something. It's the absence of photons hitting your retina, but it's still a concept your brain can process. Imagine instead the absolute void before existence. No space, no time. No laws of physics. No quantum fields humming with potential. Nothing. Now open your eyes. Where did everything come from? This is the question that has haunted humanity since the first conscious being looked up at the stars and felt that primal wonder mixed with existential dread. Where did all this come from? Why is there something instead of nothing? And more disturbingly, could it all disappear back into nothingness just as mysteriously as it appeared? For centuries we told ourselves stories. Gods breathed life into the void. Cosmic eggs cracked open. Eternal cycles of creation and destruction spun like wheels in the darkness. These weren't just religious myths. They were the only frameworks our ancestors had for grappling with the impossible paradox of existence itself. Then came science. Then came mathematics. Then came a revolution so profound that we're still processing its implications a century later. In 1927, a Belgian priest and physicist named Georges Lemaitre proposed something that seemed like madness. The universe had a beginning. Not just a transformation from one state to another, but an actual starting point. A moment, or something like a moment, when everything that is, was, or ever will be was compressed into a space smaller than an atom, smaller than a proton, smaller than anything you can imagine because human brains didn't evolve to comprehend scales that extreme. the scientific community reacted with the intellectual equivalent of laughter. Even Einstein, who had already revolutionized physics twice over, initially rejected the idea. A beginning? Impossible. Absurd. The universe was eternal, unchanging, infinite in all directions through space and time. It had to be, because if it had a beginning, then what came before? And that question, that terrible, unanswerable question, was something science couldn't touch. But then came the evidence. Edwin Hubble aimed his telescope at distant galaxies and discovered something that should have been impossible. They were all moving away from us, all of them, in every direction, as if the entire universe was expanding, stretching, growing like a balloon being inflated by invisible breath. And if the universe was expanding now, then logically, mathematically, it must have been smaller yesterday, smaller last year, smaller 1,000,000 years ago, smaller 1 billion years ago. Keep rewinding the cosmic film, and eventually you arrive at a frame where everything, all the matter, all the energy, all the space itself, was condensed into a single point of infinite density and infinite temperature. We call it the singularity, the moment of creation, the Big Bang. But here's what they don't tell you in school. The Big Bang theory doesn't actually explain the Big Bang. It explains what happened after, the expansion, the cooling, the formation of particles and atoms and stars and galaxies. But the moment itself, that first instant, that remains shrouded in a mystery so profound that our best equations literally break down. They produce infinities. Nonsense. Mathematical gibberish. It's as if the universe is hiding something from us, protecting a secret at the heart of creation that we're not meant to understand. Or maybe, and this is where things get interesting, maybe we've been asking the wrong questions all along. See, we've been obsessing over when the universe began and how it expanded. We've been treating the Big Bang like it was an event, a happening, an explosion in space. But space didn't exist yet. Time didn't exist yet. There was no stage for any event to occur on, no clock to measure duration, no before and after. So, what was there? Energy. Pure, undifferentiated, unimaginably concentrated energy. And according to the most fundamental laws of physics, laws so basic they seem almost boring, energy and light are the same thing. EMC2. Energy equals mass times the speed of light squared. But flip that equation around, and you get something even more profound. Mass is just frozen light. Matter is just energy moving below the speed limit of the universe. Everything you've ever touched, everything you've ever seen, every atom in your body, every star in the sky, every planet, every black hole, every galaxy, it's all just light that got tired, light that slowed down, light that crystallized into the solid, tangible, seemingly permanent structures we mistake for reality. But reality is fluid. Reality is light. And at the beginning, if there was a beginning, there was nothing but light. Think about what that means. Really sit with it for a moment. At the birth of the universe, when temperatures were so high that no particle could exist in any stable form, when the density was so extreme that space itself was curved into impossible geometries, there was only electromagnetic radiation. Photons. Pure light. If we can even call it that when there were no eyes to see it, no consciousness to perceive it. The universe didn't begin with matter. It began with light, and for the first 380,000 years, a blink in cosmic time, an eternity in human time, light was the only game in town. The universe was an opaque plasma of photons and particles, so hot and dense that light couldn't travel more than a tiny fraction of an inch before being absorbed and re-emitted, in an endless chaotic dance. Then something miraculous happened. The universe expanded enough, cooled enough, that electrons could finally bond with protons to form the first neutral atoms. And in that moment, that single cosmic instant, light was set free. We call it the moment of recombination, but that's too clinical, too sterile for what actually occurred. Imagine being trapped in a prison cell so small you can't move, can't breathe, can't exist as yourself. For hundreds of thousands of years, you're crushed by the weight of existence itself. Then suddenly, inexplicably, the walls vanish. You're free. You can move. You can travel. You can rush outward in all directions at the ultimate speed, the cosmic speed limit, carrying with you the memory of where you've been and what you've seen. That's what happened to light at recombination. It exploded outward, and it's been traveling ever since. Some of those photons, ancient photons, born when the universe was a fraction of its current age, are reaching Earth right now. They're hitting satellites and telescopes, telling us stories about the early universe in a language written in wavelengths and frequencies. We call this ancient light the cosmic microwave background radiation. It's everywhere, filling every cubic centimeter of space with a faint glow at 2.7 Kelvin, above absolute zero. It's the afterglow of creation, the fossil record of the Big Bang, the oldest light in the universe. But here's what keeps me awake at night. That light was there first, before atoms, before chemistry, before planets could form, or life could evolve, or consciousness could emerge to observe it all. Light was there, witnessing everything, perhaps even causing everything. Because light doesn't just illuminate, it interacts. It pushes, it pulls, it carries momentum, it exerts pressure. Light from the sun, right now, is physically pushing against your body with a tiny but real force. If you could build a sail big enough and light enough, you could ride sunlight across the solar system like an ancient mariner riding wind across the ocean. And in the early universe, when light was far more energetic and far more concentrated, it didn't just passively witness creation, it actively participated. Photons collided with particles. They created new particles from pure energy in matter-antimatter pairs that annihilated back into light in fractions of a second. The early universe was a cosmic forge where light played blacksmith, hammering energy into matter and matter back into energy in an endless cycle of creation and destruction. So let me ask you again, more precisely this time, what if light isn't just a product of the Big Bang? What if light is the Big Bang? What if the act of creation and the existence of light are so fundamentally entangled that you can't separate them even in principle? What if the universe didn't begin at all, but rather light has always existed in some form, perhaps cycling through phases we don't yet understand, perhaps oscillating between states of intense concentration and vast expansion, perhaps playing out patterns that repeat across timescales so vast they make the current age of the universe look like a single heartbeat? I know what you're thinking. This sounds like mysticism. Like New Age spirituality dressed up in scientific language. Like I'm about to tell you that consciousness creates reality. And we're all made of star stuff and everything is connected, man. But I'm not. This isn't mysticism. This is physics. Cutting edge, peer-reviewed, mathematically rigorous physics that just happens to be so strange, so counterintuitive, so alien to everyday experience that it sounds like mysticism when you first hear it. Let me show you what I mean. Indecetodrines, quantum field theory, which is the closest thing we have to a true description of reality at its most fundamental level. Particles aren't really particles at all. They're excitations in fields, ripples in invisible oceans that permeate all of space. The electron isn't a tiny ball zipping around an atomic nucleus. It's a wave in the electron field. The photon isn't a little packet of light energy. It's a vibration in the electromagnetic field. And here's the kicker. These fields aren't made of anything. They don't exist in space. They are space. Or at least they're so intimately woven into the fabric of space that you can't separate them. Space itself is alive with these fields, humming at the quantum level with an energy that never goes away, never stops, never rests. Physicists call it the vacuum energy or zero-point energy, and it's exactly what it sounds like. Even in the perfect vacuum of space, far from any stars or planets or matter, where the temperature has dropped as close to absolute zero as physics allows, the quantum fields are still there, still fluctuating, still creating virtual particles that pop into existence and vanish in less than an instant. And the electromagnetic field, the field that gives rise to light, is one of these fundamental fields. It's not optional. It's not something that was added to the universe after creation. It's baked into the structure of reality itself. You can't have space without the electromagnetic field. You can't have time without quantum fluctuations. You can't have existence without light. So when we ask what came before the Big Bang, we might be asking a meaningless question, like asking what's north of the North Pole. The question assumes a framework, a concept of before and after, that breaks down at the boundary we're trying to examine. But if we rephrase the question, if we ask instead, what is the most fundamental thing in existence, then suddenly light becomes not just a candidate, but perhaps the only candidate that makes sense. Because light has properties that nothing else shares. Light is unique in ways that seem almost designed to make us question reality. First, light has no mass. Photons are massless particles, which sounds like a contradiction until you realize that mass and energy are interchangeable. A photon carries energy without mass, moving at the cosmic speed limit precisely because it has no mass to weigh it down. And according to Einstein's relativity, anything without mass must travel at the speed of light. It's not a choice. It's a law of nature as fundamental as existence itself. Second, light experiences no time. From the perspective of a photon, if we can even speak of a photon having a perspective, its entire journey happens instantaneously. A photon emitted from a distant star 13 billion light-years away doesn't experience those 13 billion years of travel. From its reference frame, it's emitted and absorbed in the same moment, the same eternal now. Think about what that means. Light exists outside of time. It connects distant points in space-time without experiencing the duration between them. In a very real sense, all photons exist in an eternal present moment, a timeless now that encompasses the entire history of the universe from beginning to end. Third, light is the mediator of the electromagnetic force, one of the four fundamental forces that govern all physical interactions in the universe. Every time two electrons repel each other, they do it by exchanging photons. Every chemical bond, every biological process, every thought in your brain, all of it is ultimately orchestrated by the electromagnetic force, and the electromagnetic force is carried by light. So light isn't just something we see. It's the mechanism by which matter interacts with matter. It's the messenger between particles, the carrier of information, the thread that weaves the fabric of cause and effect throughout the cosmos. And fourth, most mysteriously, light exhibits wave-particle duality. It behaves as both a wave and a particle depending on how you observe it. Ask it to be a particle, and it shows up as discrete photons. Ask it to be a wave, and it spreads out in interference patterns. It's as if light refuses to be pinned down to a single identity, as if it exists in a quantum superposition between multiple states until the moment of measurement forces it to choose. This isn't a flaw in our understanding. This is fundamental. This is what light is. Something that defies the categories we use to understand everything else. Something that operates according to rules so strange that even after a century of quantum mechanics, physicists still argue about what it all means. And here's where things get truly weird. Stay with me, because this is important. You've probably heard of the double-slit experiment. It's the most famous experiment in quantum physics, the one that broke our understanding of reality so completely that we're still picking up the pieces 100 years later. Here's what happens. You fire photons, individual particles of light, at a barrier with two narrow slits in it. On the other side, you put a detector screen to see where the photons land. Simple enough, right? If light were just particles, you'd expect to see two bright bands on the detector screen, one behind each slit, where the photons passed through. Like throwing baseballs at a fence with two gaps, most balls go through the gaps and hit the wall behind in two clumps. But that's not what happens. Instead, you see an interference pattern, alternating bands of light and dark, like ripples overlapping on a pond. This is the signature of wave behavior. The light is somehow going through both slits at once, interfering with itself, creating regions where the waves amplify and regions where they cancel out. Okay. You might think, so light is a wave, not a particle. Mystery solved. But then you do something diabolical. You fire the photons one at a time. Single photons, separated by seconds or minutes or hours. Each photon is completely alone, with nothing to interfere with. And yet, impossibly, paradoxically, the interference pattern still builds up. One photon at a time, dot by dot, the pattern emerges. Each individual photon somehow knows about both slits. It somehow takes both paths simultaneously. It somehow interferes with itself despite being a single indivisible particle. But wait, it gets worse. You decide to find out which slit each photon actually goes through. You set up detectors at the slits to watch the photons pass by. And the moment you do that, the instant you add measurement to the system, the interference pattern disappears. The photons start behaving like particles again, going through one slit or the other, creating two bright bands instead of the interference pattern. It's as if light knows it's being watched. As if the act of observation fundamentally changes what light is. This isn't speculation. This isn't interpretation. This is experimental fact, repeated thousands of times with increasing precision and sophistication. Light behaves differently when you observe it. The very act of measurement changes reality at the quantum level. And before you ask, no, it's not the equipment disturbing the system. It's not vibrations or heat or electromagnetic interference. It's measurement itself, the extraction of information that collapses the wave function and forces light to choose a definite state. So what does this tell us about light? About reality? About the nature of existence itself? It tells us that light exists in a state of pure potential until it's observed. It tells us that reality at the quantum level isn't fixed or determined until someone or something measures it. It tells us that consciousness, or at least measurement, information, observation, plays a fundamental role in shaping the universe. And if that's true at the quantum level, then what about at the cosmic level? What if the Big Bang itself was a kind of measurement? A cosmic observation that collapsed an infinite wave function of potential universes into the one specific universe we inhabit? What if light, existing outside of time, connecting all points in space-time, behaving as both wave and particle, is the mechanism by which this observation occurs? What if the universe creates itself through light? I can see you shaking your head. This is too much, too weird, too far from the solid, predictable world you walk through every day. But let me ground this in something you can verify right now. Look around you. Everything you see is only visible because of light. But more than that, everything you see is light, in a very real sense. The colors, the textures, the shapes, all of it is your brain's interpretation of different wavelengths of electromagnetic radiation hitting your retina. The red of a rose isn't in the rose. The rose is reflecting certain wavelengths and absorbing others. The redness exists in the interaction between photons and your visual cortex. Change the light source, and the rose changes color. Look at it under a sodium lamp, and it might appear black. The rose hasn't changed. Light has changed, and your perception changes with it. Now extrapolate that to the entire universe. Everything we know about the cosmos, literally everything, comes from light. We've never touched a star. We've never held a galaxy. We've never directly measured the expansion of space. All our knowledge of the universe beyond our immediate vicinity comes from collecting photons and decoding the information they carry. Those photons are ancient historians, travelers from distant realms, messengers carrying news of cosmic events that happened millions or billions of years ago. When you look at the Andromeda Galaxy, you're not seeing it as it is now. You're seeing it as it was 2.5 million years ago, because that's how long it took the light to reach you. In a very real sense, the past still exists, encoded in light that hasn't arrived yet, and the future is already determined, in a way, by light that has already been emitted but hasn't been observed. Time itself becomes fluid, negotiable, when you start thinking in terms of light's perspective. And here's something that should genuinely disturb you. We can only see a tiny fraction of the universe. The observable universe, the sphere of space from which light has had time to reach us since the Big Bang, is about 93 billion light-years across. But the actual universe? It could be infinite. It could be 1 trillion times larger. It could be one bubble in an infinite sea of bubble universes, each with its own laws of physics. We'll never know. We can't know, because the information can't reach us. The light from those distant regions will never arrive, because space itself is expanding faster than light can travel through it. There are galaxies right now, at this moment, crossing a cosmic horizon beyond which they'll be forever lost to us, their light redshifted into nothingness, their existence erased from our observable universe as thoroughly as if they never existed. So, the universe we experience, the universe we study, the universe we think we understand, it's defined entirely by light. By what light can reach us, by what light reveals. Without light, the universe doesn't just go dark. It ceases to exist in any meaningful sense. Because existence, at least for conscious observers, requires information, and information requires light. This is starting to sound dangerously close to solipsism, the idea that only your own mind exists and everything else is illusion. But that's not what I'm saying. The universe exists independent of human observation. Stars burned for billions of years before eyes evolved to see them. But, and this is crucial, the universe as we know it, the specific configuration of matter and energy and space-time that we inhabit, might not be the only possible universe. It might not even be the most probable universe. It might be just one solution to an equation with infinite solutions, one path through an infinite maze of quantum possibilities. And light is what selects the path. Light is what collapses the wave function. Light is what makes the potential actual. In the beginning, if there was a beginning, perhaps there was only a quantum foam of possibilities, infinite potential universes, all existing in superposition, all equally real and unreal. Then something happened, some quantum fluctuation, some random chance, some observer effect we don't yet understand, and light emerged. A single photon, perhaps, or a burst of electromagnetic radiation, or a coherent state of the electromagnetic field. And that light spread. It interacted, it measured, it observed. And with each interaction, it collapsed more of the wave function. It selected more of reality. It created more of the universe, not through conscious choice. Light isn't conscious, at least not in any way we understand, but through the simple act of existing, of carrying information, of mediating interactions between quantum fields. Light became the architect of reality simply by being real itself. This isn't just philosophical speculation. There are real mathematical frameworks that explore these ideas. Quantum cosmology, the study of the universe's origin using quantum mechanics, suggests that the Big Bang might have been a quantum transition from nothing, or rather, from a different kind of something, into the expanding space-time we inhabit. In some models, this transition involves the spontaneous creation of particle-antiparticle pairs from the vacuum energy. And the first particles to emerge, the first stable excitations of quantum fields, would have been photons. Light. Because photons are massless, they're the easiest particles to create from pure energy. They require the least amount of effort from the quantum fields. So it's not unreasonable to imagine that light was literally the first thing to exist after the Big Bang. Or perhaps even during the Big Bang, if we can speak of during at such a singular moment. And if light was first, if light emerged from nothingness carrying with it the seeds of all subsequent creation, then in what sense is light not the creator? You might object, but light is just electromagnetic radiation. It's just photons. It's just a byproduct of more fundamental processes. Surely the quantum fields themselves, or the laws of physics, or the mathematical structures underlying reality, Surely those are more fundamental than light. Maybe. But here's the thing. We don't actually know what quantum fields are made of. We don't know why the laws of physics have the specific forms they do. We don't know why mathematics describes reality so unreasonably well. These are all mysteries wrapped in deeper mysteries. What we do know is that light exists. It's measurable. It's reproducible. It's the same everywhere in the universe, governed by the same electromagnetic laws, moving at the same speed, exhibiting the same bizarre quantum properties. Light is the one thing we can point to and say, this is real, this exists, this connects everything, and maybe that's enough. Maybe the search for something more fundamental is a fool's errand. Maybe we keep trying to dig beneath light to find something deeper, because we can't accept that something so familiar, so everyday, so woven into our moment-to-moment experience, could also be the most profound and mysterious thing in existence. We see light as ordinary because we're bathed in it constantly. We take it for granted because it's everywhere. But ordinariness doesn't imply simplicity. Familiarity doesn't imply understanding. You've been seeing light your entire life, and you still don't really know what it is. Nobody does. We have equations that predict its behavior with stunning accuracy. We have technologies that manipulate it to do everything from transmitting information across the planet, to cutting through steel, to reading the quantum states of individual atoms. But the fundamental nature of light, what it actually is in itself, independent of our measurements and theories, remains profoundly mysterious. And perhaps that mystery is a clue. Perhaps the universe protects its deepest secrets by hiding them in plain sight, wrapped in the familiar, disguised as the ordinary. After all, what better place to hide the truth about creation than in the one thing that allows us to see anything at all? What if every time you turn on a light, you're not just illuminating a room, you're participating in an echo of creation itself, recreating on a tiny scale the first moment when electromagnetic radiation flooded through the cosmic void? What if every sunset you've ever watched is a reminder, written in colors across the sky, that light came first? Light was there at the beginning. Light is the oldest thing in existence. What if the reason we find beauty in light, the reason we're drawn to sunrise and sunset, and starlight and candlelight, and the play of shadows and the gleam of reflection, is because, at some deep, evolutionary, perhaps even quantum level, we recognize light as our source? We are made of atoms that were forged in stars. That much is true and well known. We are, quite literally, star stuff. But those stars burned through nuclear fusion, converting mass into energy, creating light, and that light streamed out into space, where some of it, eventually, reached Earth and powered the photosynthesis that created the oxygen you're breathing right now. So we're not just made of star stuff. We're made by light. We're sustained by light. We exist in a thin film on a rocky planet, specifically because that planet sits in the Goldilocks zone where starlight is strong, enough to provide energy but not so strong it strips away our atmosphere. We are creatures of light, children of the cosmic dawn, products of that first moment when photons began their eternal journey through an expanding universe. And if light created us, if light is responsible through a long chain of cause and effect for consciousness and intelligence and civilization, then maybe we're not separate from light at all. Maybe we're just light that learned to think, light that became aware of itself, light examining its own nature through billions of years of evolution and scientific progress. Maybe the universe isn't trying to hide its secrets from us. Maybe it's trying to reveal them, using the only tool it has, light. The same light that witnesses creation is the light that allows us to understand creation. The same electromagnetic radiation that emerged from the Big Bang is the radiation we use to study the Big Bang. The universe uses light to know itself, and we are the mechanism by which that knowing occurs. If that's true, if that's even partially true, then you're not just an observer of the cosmos. You're not just a random collection of atoms that happen to achieve consciousness on an insignificant planet around an average star. You're the universe observing itself. You're light examining light. You're creation trying to understand creation. And suddenly, the question isn't, how did the universe begin? The question is, how did the universe become aware that it exists? Because awareness requires observation. Observation requires measurement. Measurement requires interaction. And interaction, all interaction, every force, every exchange of information at the quantum level is mediated by fields, by particles. By light, light is the nervous system of the cosmos, the network through which information flows, the medium through which cause and effect propagate. Without light, the universe would be isolated, disconnected, a collection of independent points with no way to influence each other. No way to know each other exists. Light binds reality together. And maybe, just maybe, light is reality. Everything else is just different arrangements, different manifestations, different expressions of that one fundamental thing. The photon you see bouncing off this page, and the electron in your retina, and the proton in the atom, in the paper and the gravitational field curving space-time around the Earth, all of it is excitations in quantum fields. All of it is waves in the invisible ocean. All of it is, in some sense, the same stuff expressing itself in different ways. And the common thread, the universal language, the one thing that connects every particle to every other particle across billions of light years and billions of years of time, light, always light. From the beginning, if there was a beginning, until the end, if there will be an end. Light was there first, light will be there last, and everything in between, that's just light playing with itself, dancing with itself, creating and destroying and creating again in an eternal cosmic performance. So when you ask, could light be the true creator of the universe? You're not asking a simple question. You're asking whether the most familiar thing in your experience, the thing you literally cannot live without, cannot see without, cannot exist without, is also the most profound mystery in physics. And the answer, strange as it sounds, impossible as it seems, might just be yes. But we're only at the beginning of this journey. We've only just opened the door. Because if light is the creator, then we need to understand what that means. How does it work? What are the mechanisms? What are the implications? And most importantly, what does this tell us about ourselves, about consciousness, about meaning, about whether any of this, all of this, the entire cosmos, whether it exists for a reason or emerged from pure chance? The answers are waiting, hidden in equations and experiments, encrypted in the cosmic microwave background, written in the wavelengths of distant starlight, encoded in the quantum behavior of photons in laboratories around the world. The universe is speaking to us in light. It's been speaking since the beginning. We're only now learning to listen. Here's what you think you know. The universe is 13.8 billion years old. It began as an infinitesimal point of infinite density and has been expanding ever since. Simple. Clean. A story with a beginning, a middle, and, presumably, an end. But let me show you where that story starts to crack. The early universe wasn't just hot, it was a furnace where time itself was still learning to move, where space hadn't yet decided how to behave, where the laws of physics were more like suggestions, flexible and strange, operating in regimes so extreme that our best theories simply shrug and admit defeat. In those first moments, and we're talking about fractions of a second so small they make nanoseconds, look like geological epochs, the universe underwent a period called inflation, not expansion. Inflation. The difference matters. Expansion is what's happening now. Space stretching gradually, galaxies drifting apart like boats on an ocean that's slowly getting wider. It's steady, predictable, governed by equations we understand. Inflation was something else entirely. Imagine the entire observable universe, everything you can see, everything we've ever detected with our most powerful telescopes, all 93 billion light-years of it, compressed into a space smaller than a marble. Now imagine that marble doubling in size, then doubling again, and again, and again, except each doubling happens not in seconds or milliseconds, but in units of time so brief that light, the fastest thing in the universe, can't even cross the width of a proton before the next doubling occurs. The universe inflated by a factor of at least 10^26 in less than 10^32 seconds. That's not a typo. That's not an exaggeration. That's what the mathematics and observations tell us happened. Space itself expanded faster than light can travel, creating more space, which expanded faster still, in a runaway process that sounds more like a cosmic glitch than a controlled beginning. And then, just as suddenly, it stopped. Why? We don't know. What triggered it? We don't know. What caused it to end at exactly the right moment to produce a universe capable of forming matter and structure and eventually life? We really don't know. But here's the part that should make you deeply uncomfortable. During inflation, space expanded faster than light, which means there are regions of the universe, vast regions, potentially infinite regions, that are forever beyond our ability to see or measure or detect. They exist. They're real. They're made of the same stuff as the universe we inhabit. But they're separated from us by an impassable boundary, a cosmic event horizon beyond which no light can ever reach us. If the universe has no edge, then where does it begin? If space itself is infinite, then was it always infinite, even at the Big Bang? How do you compress infinity into a point? These aren't rhetorical questions. These are genuine paradoxes at the heart of cosmology, and every attempt to resolve them leads us back to the same strange conclusion. We can't talk about the beginning without talking about light. We can't understand space without understanding electromagnetic radiation. We can't separate creation from the one thing that makes creation observable. The stage is set. The players are in position. But the script? The script might be written in wavelengths we're only beginning to decode. In 1965, Roger Penrose did something that would earn him a Nobel Prize 55 years later. He proved that singularities are inevitable, not probable, not likely, inevitable. If you accept Einstein's general relativity, and every experiment ever conducted says you should, then you must accept that under certain conditions, space-time itself collapses into points of infinite density. Black holes aren't exotic oddities scattered randomly through the cosmos. They're mathematical certainties, written into the fabric of reality itself. But here's where Penrose's work becomes terrifying. The same mathematics that predicts black holes also predicts the Big Bang singularity. The same equations that describe the end of matter, crushed beyond recognition into a point where physics breaks down, also describe the beginning of everything. Imagine reality as a film reel, where time is not flowing, but every moment already exists, frozen in place. Past, present, future, all laid out simultaneously like frames on celluloid. You experience time as movement only because your consciousness is reading the frames in sequence, creating the illusion of progression. But from outside the film, from the perspective of something not bound by time, all moments are equally real, equally present. This is called the block universe theory, and it's a direct consequence of relativity. Einstein himself struggled with it. If the future already exists, then where is free will? If the past is still real somewhere in space-time, then what does it mean to say something is gone? And light sees all of it at once. Remember, from a photon's perspective, there is no journey. Emission and absorption happen in the same eternal moment. The beginning and end of the universe are simultaneous events in light's reference frame. So what if the Big Bang singularity and the potential Big Crunch, or Big Rip, or heat death aren't separate events at all? What if they're the same event, viewed from different positions along the film reel? What if the universe is a closed, time-like curve, a loop where the end feeds back into the beginning, and light is the medium that completes the circuit? Physicist John Wheeler proposed something even stranger: the delayed choice experiment. He imagined a photon from the edge of the observable universe, emitted billions of years ago, traveling through space until it encounters a gravitational lens, say, a massive galaxy. The photon can take two paths around the galaxy, arriving at Earth from two different directions. Here's the twist. You can choose, right now, whether to measure which path the photon took, or to let both paths interfere with each other. And your choice, your measurement in the present, retroactively determines what the photon did billions of years ago. The past isn't fixed until you observe it. Reality remains in superposition until consciousness collapses the wave function. Wheeler's experiment has been performed multiple times, and it works exactly as predicted. The implications are staggering. Observation doesn't just reveal reality. It creates it retroactively, backwards through time. And if that's true for a single photon, what about the cosmic microwave background? What about all the light that's been traveling since the universe became transparent? We're not just observing the early universe. We might be participating in its creation, reaching back through time with our telescopes and equations, collapsing 13 billion years of quantum superposition into a single, definite history. But even that assumes time is linear. What if it's not? Kurt Gödel, the same mathematician who proved there are true statements that can never be proven, found a solution to Einstein's equations that allows for closed time-like curves, time loops, paths through space-time where you can travel into your own past. Einstein was horrified. He tried to find a way to exclude Gödel's solutions, to prove they couldn't exist in our universe. He failed. The mathematics allowed it. Reality might allow it. And if time can loop back on itself, then the question, when did the universe begin, becomes meaningless. It's like asking which point on a circle is the start. Now let's talk about what scientists actually argue about when they gather at conferences and peer behind their equations at 3 in the morning, staring at whiteboards covered in symbols that describe things no human will ever directly witness. The information paradox, Stephen Hawking's masterpiece and his greatest torment. Black holes, Hawking proved, emit radiation. They evaporate. Over timescales that make the current age of the universe look like a blink, black holes slowly leak their mass back into the universe as particles and, yes, light. Hawking radiation. But here's the problem. When a black hole evaporates completely, what happens to the information about everything that fell into it? Every particle, every photon, every detail about the matter that crossed the event horizon, it all seems to be destroyed, erased from reality, except quantum mechanics says information can't be destroyed. Ever. It's a fundamental law, as inviolable as the conservation of energy. Information can be scrambled, hidden, transformed beyond recognition, but never truly destroyed. For decades, this paradox split physics into warring camps. Some said information is preserved somehow, encoded in the Hawking radiation in ways we don't yet understand. Others said maybe, just maybe, quantum mechanics needs to be modified. Still others proposed that information escapes into other universes through quantum tunnels we can't detect. Hawking himself changed his mind multiple times before his death. The problem remains unsolved. But notice what the debate centers on. Light. Hawking radiation is predominantly photons. The information that might or might not be preserved is information about quantum states, about fields, about interactions, all mediated by light. If we can't even agree on whether information survives a black hole, how can we claim to understand what happened at the Big Bang, where the entire universe was essentially a reverse black hole, a white hole, exploding outward instead of collapsing inward? Then there's the fine-tuning problem, which sounds boring until you realize how disturbing it actually is. The universe has about 30 fundamental constants, numbers like the strength of gravity, the mass of the electron, the cosmological constant that controls the expansion of space. These numbers aren't determined by any deeper theory we know. They just are. But if you change any of them, by even a tiny fraction, the universe as we know it becomes impossible. Stars don't form, atoms don't hold together. Space expands so fast that matter can never clump into galaxies, or collapses so quickly that everything crunches back into a singularity before chemistry can begin. The odds of these constants randomly having values that allow for complexity, structure, and life. Astronomically small. So small that invoking chance seems absurd. 3 solutions present themselves, each more unsettling than the last. First, we're special. The universe was designed, intentionally tuned to produce observers. This is the anthropic principle taken to its theological extreme, and most scientists recoil from it because it smells like giving up on explanation in favor of purpose. Second, we're not special. There are infinite universes, each with different constants, and we obviously exist in one that allows existence. This is the multiverse hypothesis, and it's either the most elegant solution or the least scientific idea ever proposed, depending on who you ask. How do you test a theory about universes you can never observe? Third, the constants aren't random. They're determined by some deeper theory, quantum gravity, string theory, something we haven't discovered yet. And when we find that theory, we'll understand why the numbers have to be what they are. This is the hope that drives theoretical physics forward, the faith that understanding is always possible if we dig deep enough. But all three solutions have something in common. They're trying to explain why light can exist, why the electromagnetic force has exactly the strength it does, why photons are massless, why the speed of light is 219,900 meeting 9.87 140.2 meters per second and not some other value. Because if light were different, if the electromagnetic constant were even slightly altered, chemistry fails. Atoms become unstable. The universe fills with radiation, but never produces anything complex enough to observe that radiation. Light's properties aren't arbitrary. They're precisely calibrated to allow for a universe that can think about itself. Coincidence? Fine-tuning? Inevitable consequence of unknown laws? The scientific community is genuinely divided. Papers are published. Careers are made and destroyed. Philosophical positions masquerade as physics. And physics bleeds into philosophy, without anyone quite knowing where the boundary lies. And underneath it all, unaddressed and uncomfortable, sits the possibility that none of these paradoxes can be resolved without understanding what light actually is. Not mathematically, not operationally, but fundamentally, ontologically, as a thing in itself, rather than a tool we use to probe other things. What if we've been studying the messenger so long we forgot it might also be the message? Stop for a moment. Put down whatever you're holding. Feel your heartbeat. That steady rhythm. That proof you're alive. That mechanical pulse pushing blood through vessels. It's happening right now, in this moment, which you experience as the present. But according to everything we've just explored, now doesn't exist. Not really. Not in any objective sense. Your past self, reading the first words of this script, still exists somewhere in space-time. Your future self, finishing these words or abandoning them halfway through, already exists in that same eternal block. You experience time as movement only because you're trapped inside it. Like a character in a book who believes the story unfolds moment by moment, unaware that all the pages exist simultaneously. If time is an illusion, then everything you've ever done, every choice, every regret, every moment of joy or suffering has already happened infinite times before, and will happen infinite times again. You're not experiencing life. You're trapped in a loop, reading from a script written before the universe began, before time itself meant anything. And light saw it all. Every version of you, every possible timeline, every quantum branch where you made different choices. Light connects them all, existing outside time, witnessing your entire existence, birth to death, in a single, eternal instant. Does that comfort you? Or does it fill you with a dread so profound you want to stop reading? Because here's what really keeps physicists awake at night. What they whisper about over drinks, but rarely commit to paper. What if the universe is alive, and we are just its fleeting thoughts? What if consciousness isn't something that happened to emerge from matter, but something fundamental, woven into the fabric of reality itself, and our individual awareness is just the universe experiencing itself through temporary, localized perspectives? You've felt it before, even if you've never named it. That moment staring at the stars when you suddenly realize how small you are, how brief. You, with all your memories and relationships and carefully constructed identity, are a pattern of atoms that will disperse, a temporary arrangement of particles that existed in countless other forms before you, and will exist in countless other forms after you're gone. In 100 years, no one alive will remember your face. In 1,000 years, your name will be forgotten. In 1,000,000 years, humanity itself might be extinct or evolved into something unrecognizable. In 1,000,000,000 years, the sun will have expanded, boiling Earth's oceans, sterilizing the surface, erasing every trace that we were ever here. And in 1,000,000,000,000 years, long after the last stars have burned out and the universe has gone dark and cold, after even black holes have evaporated into Hawking radiation, there will still be light. Photons from the cosmic microwave background, stretched by expansion into wavelengths kilometers long, carrying information about the universe's birth through an endless night that might never end. Light will outlive everything, including you, including humanity, including every work of art, every scientific achievement, every act of love or cruelty our species has ever committed. We are ephemeral. Light is eternal. And if light is the creator, if light is the fundamental thing from which everything else emerges, then we're not just insignificant. We're temporary fluctuations in an electromagnetic field, ripples on an infinite ocean that will smooth out and disappear as if we never existed. That's the weight of what you've learned. That's the existential abyss opening beneath your feet. But wait, before you spiral into nihilism, before you decide nothing matters because everything is temporary and small and meaningless against the vast indifference of cosmic time, consider this. You are the universe becoming aware of itself. You are light that learned to think. For a brief, impossible, miraculous moment, the electromagnetic field has arranged itself into a pattern complex enough to contemplate its own existence. The universe has been expanding for 13.8 billion years, and for most of that time, it was unconscious. Dumb matter following blind laws, light traveling through emptiness, stars burning without anyone to see them burn. Then, on at least one small planet around one ordinary star in one galaxy among trillions, something extraordinary happened. Matter became aware. Light became conscious of itself. You are that awareness, that consciousness, that impossible moment when the universe opens its eyes and sees. And suddenly, the question isn't whether you matter against the cosmic scale. The question is, does the universe matter without you to observe it? Here's what we've been circling around, what every equation and paradox and observation has been trying to tell us. The universe doesn't have a creator. The universe is creation, an ongoing, self-perpetuating process where light both witnesses and generates reality simultaneously. Let me show you how it works. At the Big Bang, or what we call the Big Bang, there was an eruption of pure energy. That energy became light. That light began to propagate, to spread, to interact. And with each interaction, each collision between photons and particles, each quantum measurement encoded in electromagnetic fields, the wave function collapsed. Possibility became actuality. The universe selected itself from infinite potential versions. But here's the twist that changes everything. The light from that moment is still traveling. The cosmic microwave background isn't just ancient history preserved in radiation. It's active. It's still propagating. It's still carrying information. It's still making measurements, still collapsing wave functions, still creating reality as it goes. Which means the Big Bang isn't finished. It's still happening. Right now, every photon from the early universe that hasn't been absorbed yet is still in the process of creating the cosmos, one quantum interaction at a time. And we, sitting here 13.8 billion years later, pointing our telescopes backward in time, collecting those ancient photons. We're not just observing the past. We're participating in it. Our measurements of the cosmic microwave background are quantum observations that retroactively collapse the wave function of the early universe. Wheeler was right. The universe is a participatory phenomenon, but it's not just our measurements that matter. It's every measurement, every observation, every interaction across all of time, past, present, and future, all happening simultaneously from light's timeless perspective, all contributing to the single, self-consistent history we experience as reality. The universe creates itself through observation, and light is the mechanism, the carrier, the agent of creation. Picture it. 13 billion years ago, light bursts forth from an infinitely dense point. It spreads outward, carrying with it the potential for infinite universes. But as it travels, as it interacts, as it gets absorbed by matter and re-emitted and absorbed again in an endless dance, it makes choices. It collapses possibilities. It selects one specific path through the quantum maze. Fast forward to now. Human consciousness, itself a product of chemical reactions powered by starlight, mediated by electromagnetic signals between neurons, builds telescopes. Those telescopes collect ancient light. They measure it, and in measuring it, they reach back through time and help determine which path the universe actually took. We're not separate from creation. We're part of the mechanism. The universe used light to create matter. Matter created us. We observe light, and that observation completes the circuit, closes the loop, makes the whole process self-consistent. It's a cosmic bootstrap, the universe pulling itself into existence by its own quantum shoelaces. But here's the part that should make your blood run cold. What if this process has no beginning and no end? What if the universe is already dead, already reached heat death, maximum entropy, the final state where no more change is possible, and what we're experiencing, this vibrant cosmos full of stars and life and consciousness, is just the last echoes bouncing around in a closed, time-like curve? A loop of light circling back on itself, replaying the same history over and over, creating the illusion of progress, of time, of change? Or worse, what if we're living in the gap between observation and collapse? What if the wave function hasn't fully collapsed yet? What if reality is still deciding what it wants to be? And every choice you make, every thought you think, every measurement you perform with your consciousness is tilting the balance, voting on which version of the universe gets to be real? Look up at the night sky. Right now, Photons that have been traveling for millions of years are hitting your eyes. Galaxies whose light began its journey before humans existed are finally arriving at your retina. And in receiving that light, in observing it, you're making a quantum measurement that determines, retroactively, what path those photons took through space. You're reaching back through time with every glance at the stars. If the universe is infinite, if space truly has no edge and time truly has no beginning, then somewhere out there, separated from you by distances that make billions of light-years seem trivial, another version of you is reading these exact words. Another version just finished. Another version never started. Infinite copies, infinite variations, all existing simultaneously in the eternal now that light perceives. And all of them, every single one, every version of you across every quantum branch and cosmic horizon, are made of the same fundamental thing. Light that forgot it was light. Light that crystallized into matter. Light that became conscious. Light examining its own reflection in the mirror of existence, wondering where it came from, never quite realizing it's both the question and the answer. So where does this leave us? We started with a simple question. Could light be the true creator of the universe? We dove through quantum mechanics, relativity, cosmology, paradoxes that break our brains, and observations that refuse to make sense. We've seen how light emerged first, how it mediates all interactions, how it exists outside time while creating time, how it might be both the witness and the architect of everything that exists. But we haven't answered the question. Not really, because maybe it's not the kind of question that has an answer. At least, not one that fits into human language or human concepts. What we've discovered instead is something more profound and more unsettling. The universe isn't a static thing that was created once and now just exists. It's a process, an ongoing act of creation that never stops, never pauses, never reaches completion. And light is the verb, not the noun. Light is the doing, not the thing. You are part of that process. Every time you open your eyes, every time you observe anything at all, you're participating in the cosmic act of creation. You're collapsing wave functions. You're selecting reality from infinite possibilities. You're reaching backward through time and forward into the future simultaneously, just by being conscious, just by being aware. The universe needed 13 billion years of preparation. Stars forming and dying, heavy elements being forged in supernovae, planets coalescing, chemistry becoming biology, life becoming consciousness, just so it could look at itself, just so light could become aware of being light. And now, here you are. An impossibly complex arrangement of atoms and electromagnetic fields, thinking about electromagnetic fields, wondering about atoms, contemplating the very forces that allow contemplation to exist. If that doesn't fill you with wonder, I don't know what will. But I want you to sit with one final question, one last thought to carry with you when you close this and go back to your ordinary life, your daily routines, your comfortable assumptions about how reality works. If light creates reality through observation, and if consciousness is what allows observation to occur, then what happens in the vast regions of space where no conscious being will ever exist? The cosmic voids between galaxy superclusters, the regions beyond the observable universe, the infinite expanses of space-time that will never be witnessed by any mind. Do they exist? Are they real? Or is reality itself, the very fabric of existence, dependent on consciousness, dependent on observation, dependent on light interacting with awareness in ways we're only beginning to understand. And here's the truly disturbing follow-up. What happens if consciousness ends? If humanity goes extinct, if all life in the universe eventually dies out, if the cosmos goes cold and dark and nothing remains that can observe, that can measure, that can collapse the wave function, does the universe continue to exist? Or does it need us more than we need it? Think about that tonight when you look up at the stars. Those photons traveled for years, decades, centuries, millennia to reach your eyes. They existed in a quantum superposition of all possible paths until the moment they hit your retina. And in that moment, you reached back through time and determined which path they actually took. You didn't just see the stars, you helped create them. The story of light and creation isn't finished. It's still being written. Every observation adds a new page. Every measurement contributes a new verse to the cosmic poem. And every conscious being, every mind that can wonder, that can question, that can look up at the sky and feel that primal awe, is an author collaborating on a work that has no final chapter. We are light that learned to see itself. And maybe, just maybe, that was the whole point all along. The universe may have no end, but maybe neither do you.